Now let's look at indirect proofs. So basically there are two types of indirect proofs, contrapositive proofs and proofs by contradiction. So first we look at contrapositive proofs. So we have already seen that P implies Q is logically equivalent to negation of Q implies negation of P. Remember, if P is a doctor, she is a graduate. If P is not, if Q is not, if P is not a if P is not a graduate, she is not a doctor. So that was your contrapositive. So P implies Q is logically equivalent to the negation of P implies negation of Q. So instead of proving this, so if I ask you to prove this, you can as well prove this thing and then claim ki since you have proved the contrapositive, the original statement is automatically true. So the theorem is if n is an integer and n square is even, then n is even. Okay. So the theorem is if n square is even, then n is even. Okay. So this is my statement P and this is my statement Q. I have asked you to prove P implies Q, which is logically equivalent to negation of Q implies negation of P. Now negation of Q is n is even, the negation of this would be n is odd, and this has to be equivalent to n square is odd. Okay, so this is what you need to prove. Now we have done this proof in the previous part, that if n is odd, n square is odd. So you have automatically shown this to be true. So if this is true, then this is true as well. Okay. So that's your proof for this theorem. Okay. Similarly, you can look at the proof for this theorem, and you will see that this also uses the contrapositive logic. Now let's look at the second indirect proof, that is proof by contradiction. This is the most important technique to go about proofs. So whenever you get a proof in ISI exam, I'll always recommend to think about proving by contradiction. So what is proving by contradiction? So this method of proof employs the fact that if say is a contradiction, that is a statement that is always false. So we talked about falsities and contradictions. So we talked about three kinds of statements: tautologies, contradictions, and statements which are not always true or false. So contradictions were the statements which were always false. So if we have a contradiction C, then if you have two statements that P and not of Q leads to a contradiction, then P must imply Q. Okay. So what I am saying is that suppose you have to prove that P implies Q. Okay. So instead of proving that, what you show that if P is true and Q is false, this leads to a contradiction. Okay. So if P is true and Q is false, it leads to a contradiction. So this is basically saying that P and not of Q, this would imply some contradiction C, I do not know what kind of contradiction. Some contradiction could be 1 equals to 0 or 10 is greater than 50, something like that. So you will get an obvious contradiction by assuming that P is true and Q is false. Okay. So for example, the statements were P is X is a doctor and Q is X is a graduate. So what I am trying to say is, suppose you have a person who is a doctor but he is not graduate, then how did he become a doctor? Okay, so how did you become a doctor if you are not a graduate? So that's what we are trying to do here. So let's take this theorem as an example, that let A be greater than 0 is a real number. Now if A is greater than 0, then 1 by A is also greater than 0. Okay. Now we suppose that the statement a greater than 0 is true, but the statement 1 by a greater than 0 is false. So this is your statement true. We have to prove this statement q, that 1 by a has to be greater than 0. Okay. So my theorem says that prove that if a belongs to R is a greater than 0, then 1 by a is also greater than 0. This is what I need to prove. So a greater than 0 is my statement P, and 1 by a greater than 0 is my statement Q. So what I am going to do is, first step is assume that P is true and Q is false for some A. Okay, so I am saying that there exists some A for which P is true and Q is false. So this is what we are trying to do, P and not of Q. Okay, so P and not of Q in this context means that A is greater than 0 and 1 by A is less than 0. Okay, so 1 by A is less than 0. So if you multiply these two things, so A multiplied by 1 by A, it will be less than 0. So A is positive, A is a positive number, 1 by A is a negative number. So you multiply a positive and a negative number, you get a negative number. Alright, so we are saying A into 1 by A must be less than 0, which implies now A into 1 by A, it has to be 1 less than 0. Now 1 less than 0 is a contradiction. It's an obviously false statement. So we have arrived at a contradiction, and that's why we say that the assumption is false. This assumption is false, which means that the original statement is true. Okay, so that's how you construct your proof by contradiction.